We will now begin the keynote address.
Okay. Okay, ladies and gentlemen, welcome to 15th Rakuten Technology Conference. Wow, it's 15 times. Time flies like an arrow, and I cannot believe we have done this more than 10 times. But I'm very, very happy so that we are having so many very distinguished engineers and scientists joining here, and to the speakers and so forth. Today, I want to talk about two things. One is where Rakuten is right now and where we are going. And more importantly, second topic is the Japanese innovativity. Because we are doing this event in Japan. Rakuten is a Japanese company, but we're trying to globalize it. So I would like to share the importance of the diversity in tech field, as well as the potential of Japanese innovation. Begin with, I just want to show you the snapshot of Rakuten, the group. The first slide, please. So this is where we stand right now. I started Rakuten in 1997. So this is our 20th anniversary year. And then we started from 2 people. Now we have over, 20,000 people. And many engineers all over the world, more than 20 offices outside of Japan. The first month we opened Rakuten was the May of 1997. Our transaction volume was about $3,000, and out of which I was buying almost 2,000. So the real GMV was 1,000. Now our global GTV is over $100 billion, including all these the credit card payment and everything. That's fiscal year 2016. So most likely we will grow over 20% this year. The domestic e-commerce, including Rakuten Ichiba, Rakuten Travel, and everything, is about 27 billion last year, and it is of course going to go over 30 billion this year. The global membership, 1.1 billion, including Viber and everything, and in Japan we have over 90 million registered members and 85 million credit cards on the file. So that's where we are right now. Of course, we have a big revenue, very good profit. But more than anything, our ambition is not just stay as a Japanese domestic internet company, but yet become one of the top global innovative companies. So how are we going to do it? Is we are trying to transition from only marketplace-centric company to more data-driven membership company with a very, very strong brand. So the brand is very, very critical strategy for us. That is why we have decided to make a very aggressive investment into the brand, including the main global partner of FC Barcelona, as well as Golden State Warriors. Those, I think, are the two best the sports associations in the world, and we are very, very honored to be able to associate a brand to all these two great organizations. So starting from this summer, we started to really change everything to Rakuten branded. Initially, there was a little bit of confusion, of course, but that's what we are going to do. If you think about what we have done in Japan, Rakuten was just an internet shopping company, but nobody believed Rakuten is just an internet shopping company, right? The Rakuten card is the biggest credit card company in Japan. Our telecom business is growing so fast. Rakuten Travel, baseball team, and so forth and so forth. We do more than 97 services in Japan, and we're connecting all these dots. I think Rakuten is the only company which has done it in the world, and we would like to replicate our success in a global scale. So overseas, this was challenging. I thought, oh my God, Rakuten sounds a very, very Japanese name to Americans and Europeans and Asians. Shall we change our brand to something a little bit more global? Or shall we stick to the Japanese name, basically, which means optimism? So we have decided to go with the Rakuten brand. So now the Viber is called Rakuten Viber, the Kobo is called Rakuten Kobo, and Rakuten TB. But because of the power of Barcelona, Warriors, and so forth, I think now Rakuten is becoming, I don't say it is already, it is becoming the household brands in US and in Europe as well. So that's where we are. And our ambition is to become global service operator. So that's the biggest difference between, for example, Rakuten and SoftBank. SoftBank wanted to become the next generation Warren Buffett, which is very, very respectful initiative, but that's not what we want to do. We want to become the very unique service company in Japan and in the world. Hence, I had to think, can we do it or not? And here comes the second topic about the Japanese innovativity. So where are we right now? We're in Tokyo, and what is the strengths and weakness of this location, Tokyo? Everybody now, almost all of you, live in Tokyo, I think, and we need to really consider, can we do it starting from here? Maybe 50, 60 years ago, nobody really believed the Japanese automobile companies can become the top automobile companies in the world, but they have done it. Nobody really believed that Sony can become the global brand, but they did it. But objectively speaking, no Japanese brand has ever become the global brand, right? But all of you know, because you're living here, Japanese service is the best. I was talking with the Sara CEO of McDonald's Japan, and I told her why McDonald's Japan service is so good, but why McDonald's US sucks so much, right? It's very, very clear that the level of the service in Japan is the best, or one of the best at least. But yet, there is no one single Japanese service company which really became global. So I started to think about, how can we do it? This should be possible. And then I have two things. How attractive Tokyo is, right? Here it is. It was kind of shocking to learn. Tokyo is the third most attractive city in the world. And if you think about San Francisco, it's number 17. Maybe Palo Alto, number 100. Yet they are the center of the technology, and Tokyo is not, right? And London became number one because of London Olympic. So there's high possibility that Tokyo may become most attractive city in the world. Oh, location we don't have any problem, right? We are more attractive. We will become more attractive than New York for sure, because of the Tokyo Olympic is coming, and we're going to make massive investment. And I think our infrastructure is so good. The food is definitely the best in the world, I think. The nightclubs are open until 5 a.m. San Francisco, you need to close at 2, right? So it is much more culturally diversified and rich city than our competitive cities such as San Francisco, Silicon Valley, maybe New York, and unfortunately, the Mumbai is number 42. Sorry about Indians, but and of course, China, Beijing number 13, Shanghai number 15, Seoul number 6. And then we need to think about we have so many non-Japanese people here, but is Japanese people innovative enough, right? And we need to think about the strengths and weakness of the Japanese culture. But if you think about it, uniqueness, definitely Japanese culture is very unique, right? We have wide range of diversity in the culture, ranging from kawaii idol culture, or the cartoons, manga, to the authentic simplicity of Zen. Steve Jobs loved probably Japanese simplicity, but probably he didn't like all this kawaii culture in Japan. But it's very, very unique. And if you think about why it's so unique, it all came from the diversity of the culture flowing into this small island, and it kind of trapped in it, and it was kind of mixed. Japanese ramen is probably better than Chinese noodles, but although it's originally from China. I had a ramen this afternoon for lunch. But curry rice is, of course, in a sense, very unique, a little bit different from Indian curry, but it's very unique. So Japanese has the ability to mix everything and kind of mix it and create a new connection and new innovation and new creative things. If you look back on, now I'm working for most advanced cancer treatment technology, started by Japanese scientists. iPS, stem cell technology, invented by Dr. Yamanaka. We have a lot of, Nobel Prize scientists, including chemistry, physics, and medical science. The optical fiber was invented by the professor at Tohoku University. The first music play hand device, Walkman, was invented by Sony. The initial concept of the smartphone was created by Japanese. But yet, our marketing is horrible, right? Our marketing is horrible. Two things, marketing is horrible. Our ability to make it global standard is horrible. If you think about, no offense to Ritz-Carlton, Ritz-Carlton is considered as the best service hotel in the world. But I bet there are hundreds or thousands of the Japanese onsen ryokans who provide better service than Ritz-Carlton, right? But yet they cannot globalize it. So I think how, as people living in Tokyo, how we can mix the strengths of Japan with the global technology and make it like a global service and as a global standard is very, very important thing we need to consider. And here comes why we have decided to change our internal language from Japanese to English. Some Japanese CEOs attacked me. Oh God, this Mikitani is crazy. He is going to destroy Japanese culture by changing language, and it's not going to succeed. CEO of Honda publicly attacked me on the Nikkei newspaper, and I said, "Fuck, it's none of your business." Anyhow, sorry about my strong. I take it back my four-letter words, but anyhow, the point is, we are in a very unique environment, and I think we have a very, very good chance to become the next Silicon Valley of Asia. Or maybe, if you think about it, look at these cities. Where else can become next Silicon Valley, right? London, Brexit, the Paris, very high tax. Well, Seoul, unfortunately, it's not that big. Singapore, yes, attractive tax system, but small and a little bit artificial. I think Tokyo has a great potential, right? The only problem is the language, because it's sometimes difficult for the non-Japanese professionals to live in Tokyo. In a short-term stay, it's okay, but longer term, they may have a little bit of the systematic issues, like the schools for the kids and so forth and so forth. As far as we can solve these issues, then I think we have a very, very good potential that Japan will become the next generation technology hub of the world. But at the same time, I don't think we can do this by just Japanese. We need to bring best and brightest from all over the world. If you think about as a Rakuten, we are competing with the global companies. No, we're not competing against an American company. We're competing against a global company, and the people who work there are not only Americans. The Americans are minority in those companies. Hence, I'm always telling to the Prime Minister and all these politicians, it is impossible for Japanese to become the very competitive technology-based company unless we globalize internally, meaning we need to bring best and brightest from all over the world, yet keep good part of the Japanese culture. High level of hospitality, high level of teamwork spirit. Those are very, very important part for us. So today, we are going to talk a lot about most advanced things. Of course, that's very cool, and we should do it. But at the same time, if you can spare just a little bit of your, thinking about why Japan is unique, good in a good way or in a bad way, and how can we become the global leader. I don't care whether it's a Rakuten or Yahoo Japan or Line or any other company. But I think that's today's topic is not about Rakuten. Today's topic is how Japan, Tokyo become a very advanced technology center in the world. So I hope you will have a very productive time and very interesting discussions, and please have a great time. Thank you very much.
Thank you very much, Mr. Mikitani. Now we'll go on to the next keynote address. Please welcome Mr. Tarja Martinussen, e-commerce company CTO and director of Rakuten Inc. Mr. Martinussen, if you please.
Hello, everybody. Thank you for coming here today. It's already halfway into the day. But welcome, everybody, to the 11th Rakuten Technology Conference. This conference has, for several years, been a distributed event. We run it in our different offices in parallel, not just in Japan, but also outside of Japan. This year, we are, of course, here in Rakuten Tower. We run the parallel events in Sapporo, Nagoya, which is the first so far. Osaka, Fukuoka, we are international, so we also have parallel things happening in Beijing and Shanghai. And in Sendai, we are collaborating with the Sendai IT Festival at the Tohoku University, where they have another 1,000 people visiting, and we broadcast some of the events there. So for the Rakuten offices, as of Thursday, we had 1,700 pre-sign-ups to join any of these events except the Sendai IT Festival. And we have more than 70 speakers across these venues. The topic this year is head, hands, and heart. This covers a lot of what's happening in the IT industry right now. There is a very nice span of things, big data, logical, mathematical, very deep, advanced things happening. We do a lot of things on robotics, drones, and a lot of things on everything around us, IoT, data, how we interact with humanity, AI. All of this is coming together in a big, nice pool of things this year. And on the hard side, I would like to also consider passion, which drives innovation, which drives entrepreneurships, which makes anything happening in the end. And a few of our sessions covers that area as well. This conference has always been a volunteer-driven event. We have many very passionate engineers in the company. They arrange this on a voluntary basis. They work some nice evenings and weekends before to find topics, speakers, and so on. And I would like to give them and a guy hidden out there, reach up your hand, Mori-san, which is the chairman of this event, a big round of applause. Traditionally, this has been my part of the tech conference, but this year, Mori-san gave me a bit more time, so I can talk about some of the topics that interest me. And in a few months, I will have spent 25 years in a paid job in IT. Most of that time has been very hands-on. It says I'm a manager, but I'm actually very hands-on in what I do. And most of my time has been spent on performance issues, scalable computing, distributed systems. And this year is incredibly fun year. You got Intel and AMD back into the boxing ring on the high-end side of processing for the first year in 12 years. They are launching new CPUs every few months that wasn't on the program. It is fascinating. You got AI and IoT driving new custom silicon. Bitcoin mining are driving custom silicons, which has been sort of not happening in the industry since the 80s, before general computing CPUs got powerful enough to do almost everything. We had a lot of fun custom silicon back then. It's been gone for the market. Being a full stack person interested in all of this, I'm all like, ooh, this is so cool. Something new was launched. Can I buy it on Ichiba? I hope my wife don't see the credit card bill. That's been my year so far. It's really fun. Most of you don't realize this, but this is a really exciting year. So to do the big problems we do, we require high-performance hardware. And if you look at the history of this hardware, this is the most common piece of server hardware out there, Intel's server CPUs. If you look at their historical scaling, this is the maximum clock frequency, or the clock frequency of the most expensive CPU from Intel every year since 1998. And you can see that those clock frequency went up very aggressively until 2004. In 2004, we hit the limits of physics. To make a transistor switch faster, you need to put more energy into it. And that brings you all kinds of problems with heating, with electrons jumping in places they shouldn't be, and we didn't get any faster. Instead, actually, we dropped down. Still, CPU got faster, and it got faster by adding more compute elements, more cores. We went from 1 core in 2004 to 28 core on Intel CPU this year, and AMD is up at 32. Fortunately, the cores also got faster. This is harder to quantify, but if you use an industry benchmark like SpecInt, each clock cycle processed 4.5 times more this year versus 10 years ago. But you can see that this curve is starting to flattening out. In the last 3 years, we only have a 10% increase in clock efficiency. But the core count has gone up a bit more than 50% from 18 to 28. So the processors are scaling up, but they are scaling out in terms of the number of compute elements, which makes life interesting for anyone programming these things. The king of this from Intel is this guy. It's a monster. You can see it doesn't even fit into your hand. 28 cores, 56 threads. It cost $10,009. The official retail price. I'm sure you can negotiate down to $9,999. But if I was going to give any of you this one, would you be happy? Who wants one? It's $10,000, guys. How many wants it? Okay, we have a few people. The problem with this, you can put this into an 8-socket server, and it's a monster. You get 448 threads, 6 terabytes of memory. Each of them is around 10 billion transistors. But the rest of the machine is going to cost a few years of your salary. So what I would do with this guy, if anyone gave it to me, is within 1 week, it's going to be on an auction site. It's an impressive piece of hardware. And this box, 8 sockets, about this tall, is roughly the power of a mid-sized data center in the late 90s. This thing, it could probably do the taxes for entire Japan if you used it efficiently. So how do we use things like this efficiently? Well, we have 2 major groups of programming languages. One group, very popular, single-threaded programming languages. So all the execution is sort of sequential, linear. Python, the favorite amongst all data scientists. Ruby, PHP, Node.js, they all run in a single thread. You're going to run 448 of these to use that machine. Multi-threaded languages, most popular is Java. They can use all these threads, but they manage their own memory. And that is difficult. Java actually can't really do more than 10 to 16 gigabytes of memory in a busy heap. So it doesn't really help me. I don't mind Java, but I don't like coffee. So the way we use these guys is we make one program, then we run a lot of copies of that program, and we spread our data across all these copies. If you can't do that, which is actually what most people do, you take that nice expensive box and you break it up using a hypervisor into smaller machines. And these machines are often quite small. This is statistics from a company called Second Watch. They make cloud management software. In 2015, they published statistics for all the customers, what instances do they use a lot, or what is used in AWS. And you can see that 62% of instances are micro, small, medium. 1 to 2 CPU core, 2 to 4 gigabytes of memory. The average mobile phone in this room is probably more powerful than those instances. That's the reality. So if you're anyway going to break this stuff up into pieces, what's going to happen? Well, we can look at doing things more efficiently than we are today and see if we can get more money to cover even bigger problems. So if you look at the left-hand side, okay, my right hand, left hand for you, you can see per clock what is the cost for 1 gigahertz of clock of cycles. All of these machines, all of these CPUs, which are current day most popular CPUs in different ranges, they have roughly the same efficiency per clock. So on the left-hand side, it's all AMD today. AMD desktop, $12 to $13 per gigahertz of clock. You go to the common cloud CPUs, they are $40 to $60 per clock, or gigahertz of clock. And that monster I just presented, the Intel 8180, it's a stunning $142 for 1 gigahertz of clock. You're going to get a good discount of that, but you're not going to get more than 90% discount to compete with those Ryzens. So time to get distributed, which is my universe. And inside of Rakuten, we studied that chart 5 years ago. And I need a lot of processing to do what I do. So we went from the big spec guys to these. This is a microserver. It uses one of those left-range CPUs, the Xeon E3. It has very fast clocks, 32 gigabytes of memory, a very fast SSD, 3 gigabytes per second in the latest iteration. If you go to Akihabara, you can put this together for 150,000 yen. But of course, we buy thousands of them, so we are a bit better off than the Akihabara price. This is the core of our big data infrastructure in reality. We churn billions of events every day through this thing from data centers and services all over the world. We use them in clusters where we put thousands together, for instance, in search. They are great for running Java. They don't have that much memory. They have very high clock speeds, so the big data guy using Python, they can run their Python single-threaded processes very fast. Going very technical, there is only one CPU here. You buy that big 8-socket machine, you get into NUMA and locality issues. You run something on this CPU, somehow the scheduler moves it to another CPU, and you have a lot of data moving around, caches being invalidated, memory being owned by this CPU, but processing happening here. All of that is gone here. You don't have to care about it. You buy a lot of processors, but this is desktop part, so it doesn't matter. It runs at 16-watt idle. Every service on the internet goes in cycles with peaks and spikes. They are very, very power efficient in those bottoms. If one node fails, this is one of my favorite aspects of this being a distributed guy. When one of these crashes, it's a small part of compute, small part of storage. It has small impact on the total system, and it recovers very quickly by copying data back. And the nicest piece of all, if you really fit into the frame of this, the cost is literally 1/3 of what you can get from any cloud provider out there, because it's consumer parts. So how do you program this guy? Same way as the big guy. You split up your job into a lot of different tasks, and you run them in parallel. So the problem I'm getting to here right now is you can see that what we are programming for most of our tasks today that are seen as very complicated, very big, is actually one piece of program which we churn a lot of data through, and we can do that by spreading out the same tasks on a large number of machines. Very few programmers or programs today effectively use a large number of threads to solve one complex problem that doesn't involve big amount of data. The reality is to program everything you have on this guy, including sensory input, screen input, and everything, you have a massively large team to do something smart about this. And you can see it even better what's happening if you compare server and desktop CPU. Server cores going up rapidly. Everybody here that has a MacBook Pro laptop, you probably had 2 cores in it in 2007. You still have 2 cores in it. It's just because we as programmers are actually not able to challenge the CPU more. Some people blame it's Intel. But if I had a program changing how we looked at CPUs, Intel would be happy to fulfill that market. But the market isn't there, so instead they focus on power saving. So basically, 10 years ago, I started seeing this trend being in distributed computing. We are just too stupid to really utilize the CPU power you actually have in a machine today. And it's going to get worse. We are focusing on trying to copy what humans do. We are challenging what humans are doing that computers cannot do. So what we are trying to do is to copy this guy, the human brain. And it's so far ahead of the most complex computers out there, like the Platinum 8180 CPU. It still has to run according to one central clock. Everything is aligned to it. And as a result, the clock has to be very high to do something useful. But the brain don't have that. Every part is asynchronously. One nerve impulse commit, and that is processed immediately, no matter what the other part of the brain does. It's amazing. We don't have anything like this created by humans today. The amount of compute elements nobody can calculate. One number I found on Google, 200 quadrillion neural synapses, etc. It's 20 million more elements than the highest, most incredible CPU we can make today. So how do we move in this direction? How can we satisfy or compete with actually what the brain does? Well, we are trying to improve production methods. Intel latest factory, $7 billion of investment, 3,000 employees, but we have a bit to compete with the human brain. It requires 2 people, 9 months, and we create something that no human can make today, even with 3,000 people and $7 billion. My favorite is this one. It shows how randomness of nature has created something we are really struggling with, competing with. That brain in here, you give it a banana, and it runs for hours. To run your CPU at 200 watts, you need a big factory that either pollutes a lot, or which, if it blows up, it destroys humans' ability to live in the region for a long, long time. And we have no way to reproduce this kind of system today, but we are working very, very hard to get there. Most importantly, which is really nice, you eat that banana, and the blood brings energy to make this thing run, but the blood also takes heat out. This is bloody clever. And any designer of CPUs would dream about making something like that today. So we program those CPUs traditionally by writing code, this case assembly, and we are trying to copy the brain because we cannot really program those complex CPU. You do supervised learning, where you have someone teaching you how to do something. You have unsupervised learning, where you try to learn by yourself, and you have reinforcement learning, where you learn by trying and failing. Same thing we do in AI today. We are basically moving in that direction, and there is no alternative for us, because we are still far from making computers advanced enough to be really intelligent. We are working hard on making them closer that way, and in the process, we are failing to program them. Already 10 years ago, I started to see that we were touching the limit of how well we can program a computer, and this is getting worse and worse. So everybody in IT are going to move from programming to training computer. It's already happening for many problems. Image processing, voice processing, any kind of pattern recognition is mostly solved better with training versus programming today. Cloud services is revolutionizing this. If you take a look at, for instance, the APIs provided by Google right now, they are amazing. You have 15-year-old kids doing really cool stuff with it. You can do machine learning that does very useful stuff literally with 50, 100 lines of code. But this is getting even more fun, because I think the future of AI don't really involve programmers. That's when it gets really powerful. Siri is learning what you say, but I'm waiting for those mobile apps, which is nothing but a framework for you to do something, and your mobile phone learn a new feature just from what you're training the mobile phone to do. And this is to come very soon, I'm pretty sure. I'm not working on it myself, but I'm sure someone has to create it very soon. So people are afraid of what kind of jobs gets lost from AI. I'm more interested in what kind of jobs gets created, because, well, this list is too short, but I think there will be a lot of new jobs created as a result of AI. From people stopping to use manual tasks, letting computers do them, but instead have to train the computer. What does it take to learn a computer to deal with accounting rather than program it? It's coming to come. You're going to send it in all the legal frameworks of Japan, and it's going to learn to do accounting for you. But you have to tell it what's right and wrong in terms of interpreting that, because it doesn't know it, and this will require a lot of people. But again, the trend is basically unavoidable over the next years. I said at the start, this would be a sort of pragmatic view on this. I can't really help to think about the fun aspects of making computers more human. Siri already seriously annoys me. But as we make computers learn more and more, this is maybe the reality, what we see of making computers learn things. I'm waiting for the Shogunai feature of Siri. Most of the thinking about what AI does to society is usually like, oh, they're going to take over all the nuclear weapons and blow humanity up. But this is maybe what you're going to more interact with as AI progress. This thing, I don't like it. Yes, it's going to be annoying. So things are going to progress here. We're going to do a lot more on hardware. Rakuten is also investing a lot in AI like anyone else. There will be more fun features around what's happening on AI, announcements in the future. Thank you. That's all I had to say today. Enjoy the rest of the conference.
Thank you very much.